Hello students, today we will discuss the chapter atoms. For the sake of simplicity, we have divided this chapter into two lectures. In the first lecture, we will be mainly talking about the Bohr's model of hydrogen atom, and in the next lecture, we will be talking about the X-rays. So today, let us talk about the Bohr's model of hydrogen atom. In this discussion today, we have to talk about that phase when electron, proton and neutron were already discovered, and one by one various models were being proposed about the structure of atom. The first model which had come, that was called Thomson model. This model was very soon rejected. This model had said that the distribution of electron, proton, neutron, everything is like the seeds in watermelon, the kind of uniform distribution it had predicted. But it was very soon rejected after the Rutherford's experiment was performed, and the Rutherford model took the prominence for some time. So next model, that was proposed by Rutherford. To a large extent, this definitely told the kind of structure existing inside the atom. The experiment which was performed by Rutherford, in that case he had taken a gold foil. The atomic number of gold, you have Z is equal to 79, and over which several alpha particles were fired. It was observed that most of the alpha particles, they passed on undeflected, because after this gold foil you must have kept some detectors on which you can measure the amount of alpha particles coming along. There was probably 1 in 20,000 particles which came back. This particular incident was very amazing for Rutherford, because the thickness of gold foil was very small and the alpha particle is treated very massive so long as the nuclear collisions are concerned. In layman language, Rutherford had described this particular event of alpha particle coming back as throwing a cricket ball on a tissue paper and coming back. You understand? जो gold foil की thickness थी, उसको हम tissue paper से compare कर सकते हैं, and alpha particle जो massive है और with kinetic energy जो बहुत ज़्यादा है, उसको हमने एक cricket ball के movement से compare किया है. और तब अगर एक tissue paper पे आप cricket ball throw करें and if it is coming back and hitting you, this will really be surprising, and based on which Rutherford could draw several conclusions. Once he experienced that alpha particle is coming back, then he thought that the most of the mass of the atom must have been confined to a particular point which he called nucleus, and it should have been positively charged, because the alpha particle itself was positively charged, and coming back means there must have been a strong repulsion. The kind of conclusion Rutherford could draw from this place was that most of the mass of the atom was confined to a particular place which he called nucleus, and he also concluded that the electrons must have been revolving around this nucleus. We will be coming on to that, but first there are few descriptions related to Rutherford model which can be asked to us. First thing we should talk about, that is the shortest or closest distance of approach. In Rutherford's model, first we will be talking about shortest or closest distance of approach, which you can denote by R0, and essentially this is the size of the nucleus as well. In this sense, let us suppose this is the size of the nucleus, and the distance up to which this alpha particle is able to come close to the nucleus, that you are calling the shortest distance of approach. Here you should understand that this alpha particle has positive charge, and that too the magnitude is 2 times electronic charge, and the total charge on the nucleus, this is Z times electronic charge, and this is also positive. This alpha particle has, say, kinetic energy K, or for the sake of simplicity let me write it has the kinetic energy Ke. You understand? This is the alpha particle coming along. Now see, when this alpha particle will be approaching the nucleus, gradually its speed must have been decreasing, and by the time it is reaching closest to the nucleus, its entire kinetic energy will be converted into the momentary potential energy. यहाँ पे charge Q1 and Q2 momentary rest पे आएंगे, so the entire kinetic energy will be converted into the momentary electrical potential energy of these two charges. And if you balance these two, then you can say kinetic energy of alpha particle, this is equal to Q1 Q2 upon 4 pi epsilon naught R naught. And from here you can calculate the value of R naught. If you write down the expression of R naught, this will become Q1 will be 2E, Q2 will be ZE. So this will be 2 times ZE square upon 4 pi epsilon naught, and the kinetic energy of alpha particle which is coming along. Generally the kinetic energy is in mega electron volt, Z is 79, E is the electronic charge, 1 by 4 pi epsilon naught, you have already seen the value 9 into 10 power 9. If you calculate all these things, then you must see that the value comes out to be around 10 to the power minus 12 centimeter. Now what is the meaning of this closest distance of approach to be 10 to the power minus 12 centimeter? The meaning of this thing is that the size of the nucleus is of the order of 10 to the power minus 12 centimeter. If you talk in terms of meter, that will be around 10 to the power minus 14 meter, maybe 10 Fermi around. This is the order of the size of the nucleus. And closest distance of approach calculation is essentially talking about the size of the nucleus. So some of the direct questions are asked on this particular value, so you should keep that thing in your mind. Now next thing is that he found that some of the alpha particles were getting deflected at some particular angle. It was the situation in which most of the alpha particle passed on undeflected. 1 in 20,000 around came back. Whatever came back, based on which we calculated the size of the nucleus. Most of the particles which were deflected, we have to look at some of the results based on that. Let us talk about that. Imagine that the alpha particle which is coming in this particular direction, it is getting deflected at angle theta. Let us suppose this alpha particle got deflected at angle theta, and from the nucleus central line, if you see the perpendicular distance, this is, I am calling impact parameter B. You understand? Impact parameter B is related to the deflection. Generally you will find that if B value is small, then theta is large. You will find that the impact parameter is proportional to cot theta by 2. Now here you see, this is the kind of result which can be obtained by several applications of conservation equations, etc. Impact parameter is directly proportional to cot theta by 2, tells you that if you are decreasing the value of B. Now what is this impact parameter? If the value of B is very small, that means you are heading towards head on collision. लेकिन अगर B की वैल्यू थोड़ी ज्यादा होगी तो 2 dimensional collision होगा. In case the value of B is very large, that means you are quite far off from the nucleus. In that case, the alpha particles will be passing on undeflected. In that case, you will see theta value will be less. But closer you are to the nucleus, that means the value of B is small, and in that case, the value of theta will become larger. Not only the impact parameter and theta relation, rather how many alpha particles are getting deflected at an angle theta, that was also correlated with the help of this expression, that number of alpha particles deflected at angle theta, that can also be proved to be proportional to cosec 4 theta upon 2. This is another relation you should keep in the mind so long as Rutherford model is concerned. So essentially, for the case of Rutherford model, we talked about three quantities. One was your shortest distance of approach formula. This is this formula. Second one we talked about, that was the relation of impact parameter with the angle of deflection. This is second formula. And the third formula is number of alpha particles deflected at a particular angle. Now, based on these conclusions, Rutherford said that there is a kind of nucleus in which protons and neutrons are existing and the electrons are rotating around it. But remember that this is the time when Rutherford had proposed his model. That was the time when Maxwell's theory was dominant, and Maxwell had already predicted and proved that the accelerating charged particles are emitting radiation. Once Rutherford said that electrons are revolving around the nucleus, then it was said that the electrons will be under accelerated motion because it's a circular motion. So definitely they must have been radiating energy. In that case, the stable circular orbits will not be possible. Rather, these electrons will be rotating in some spiral path, because gradually once the energy of these electrons that is reducing, the path will become spiral, and finally the electron will be touching the nucleus. The positive charge of nucleus and the negative charge of electron, they will be cancelling each other, and the atom on the whole will become unstable. This was the proposition of other people who criticized the Rutherford model, and because of which it remained in some suspended discussion until the Bohr's model of hydrogen atom came into picture. So let us talk about the Bohr's model of hydrogen atom. Now let us talk about the Bohr's model. The Bohr's model was valid for hydrogen or hydrogen-like atoms. Valid for hydrogen or you can say hydrogen-like. What is the meaning of hydrogen-like atoms? Meaning of hydrogen-like atoms is that it should have single electron. In other words, you can say single electron atoms. In hydrogen atom, you already have one electron, but let's suppose you talk about helium, then you have two electrons. So ionize it like this. एक electron उसमें से हम remove कर लेंगे, the only electron will be left. Or lithium has 3 electrons, let's suppose doubly ionized lithium आप ले लेंगे, तो उसमें एक single electron होगी. You understand? On the similar line, बेरिलियम को ट्रिपली आयनाइज आप करेंगे, तो ये सारे ऐसे एटम्स हैं जिनको हम हाइड्रोजन लाइक एटम्स कहेंगे, एंड हाइड्रोजन इज ऑलरेडी देयर. यू अंडरस्टैंड? तो जो भी हम ये पोस्टुलेट्स बोर के डिस्कस करेंगे, दैट इज वैलिड ओनली फॉर सिंगल इलेक्ट्रॉन एटम्स, हाइड्रोजन, हीलियम प्लस और लिथियम डबल प्लस एंड सो ऑन. द फर्स्ट पोस्टुलेट which came from Bohr, he said that the electron rotates rotates round the nucleus. Electron rotates round the nucleus in circular orbits. And the necessary centripetal force is provided by the mutual force of attraction between the nucleus and the electron, between the nucleus and the electron. You understand? This is the kind of postulate he made. In that case, if you try to represent the entire situation mathematically, then you can say the mutual force of attraction is ZE is in the nucleus and the electron is rotating, so Q1, Q2 will take the form of ZE square upon 4 pi epsilon naught R square. Let us suppose the radius of the orbit is R. Then you can say this is the force acting between the nucleus and the electron, and that should be equal to mv square by R. This is the first postulate you have. You understand? ये पहला उनका postulate था कि जो भी सिंगल इलेक्ट्रॉन है वो न्यूक्लियस के अराउंड सर्कुलर ऑर्बिट में घूम रहा है एंड द नेसेसरी सेंट्रीपिटल फोर्स इज प्रोवाइडेड बाय द म्यूचुअल फोर्स ऑफ अट्रैक्शन बिटवीन द न्यूक्लियस एंड द इलेक्ट्रॉन. नाउ द सेकंड पोस्टुलेट ही हैड, द सेकंड पोस्टुलेट proposed by Bohr was that electrons are permissible. Electrons are permissible only in those orbits in which its angular momentum is integral multiple of h by 2 pi. You understand? Electrons उसी ऑर्बिट में परमिटेड होंगी जिसमें इनकी एंगुलर मोमेंटम इंटीग्रल मल्टीपल ऑफ h बाई 2 पाई होगी. इसको अगर हम मैथमेटिकली एक्सप्रेस करना चाहें तो यू विल से दैट एंगुलर मोमेंटम एक इलेक्ट्रॉन का mvr होता है. अंडरस्टैंड? द बेसिक फॉर्मूला इज r क्रॉस mv, बट वेन एवर एन इलेक्ट्रॉन इज रोटेटिंग इन सर्कुलर ऑर्बिट यू विल फाइंड दैट द पोजिशन वेक्टर एंड द मोमेंटम वेक्टर दे आर म्यूचुअली परपेंडिकुलर टू ईच अदर, एंड इन दैट केस MVR साइन 90 MVR के इक्वल हो जाएगा एंड दिस विल बी इक्वल टू NH बाई 2 पाई. ये इनका सेकंड पोस्टुलेट था. N की वैल्यू यहां पे 1, 2, 3 एंड सो ऑन. दैट मीन्स इट्स एन इंटीजर एंड वैल्यू N इज इक्वल टू 1 मीन्स K शेल, 2 मीन्स L एंड सो ऑन. N की डिफरेंट वैल्यूज के लिए एंगुलर मोमेंटम इस तरीके से लिखा जाएगा. दिस पर्टिकुलर स्टेटमेंट वॉज वेरी रिवोल्यूशनरी बिकॉज यहां से एक क्वांटाइजेशन जैसी वर्ड जो है वो हमारी पिक्चर में आनी स्टार्ट हुई. इट वॉज अ वेरी रिवोल्यूशनरी स्टेटमेंट दैट द स्पीड और फॉर दैट मैटर एंगुलर मोमेंटम इज गेटिंग क्वांटाइज्ड. यू अंडरस्टैंड? क्वांटाइज्ड मीन्स या तो h बाई 2 पाई होगी या 2h बाई 2 पाई होगी एंड सो ऑन. तो ये अपने आप में बिल्कुल एक नया सा कॉन्सेप्ट था एंड दैट इज द रीजन वी हैव टू से दैट बोर्स मॉडल स्टार्टेड ऑफ द area of quantum mechanics. Now let us talk about the third postulate. The third postulate was very revolutionary kind, in the sense it said that so long as an electron is revolving in a particular orbit, it does not emit radiation. So long as an electron rotates in an orbit, it does not emit radiation. ये अपने आप में एक रिवोल्यूशनरी बात इसलिए थी बिकॉज दैट टाइम इट वाज द मैक्सवेल्स थ्योरी विच वाज प्रीडोमिनेंट, एंड बोर simply said that whatever Maxwell had said, that is just a special case of the quantum theory he is proposing. So he said that the radiation will be exchanged during changing of orbit. Let's suppose electron is jumping from one orbit to the other. It is jumping from one orbit to the other, say E1 minus E2. These are the two energy values in two different orbits. Orbit 1 में energy E1 है, orbit 2 में energy E2 है. In case electron is jumping from higher orbit to lower orbit, radiation is emitted. In case the electron is jumping from lower to higher orbit, it will be absorbing radiation, and the wavelength of radiation is lambda. So E1 minus E2 will be equal to hc by lambda. This is the third mathematical expression of the postulate which Bohr had given. And within these three equations itself, we have to talk about the radius, the speed, frequency, and the energy of atom, rather hydrogen or hydrogen-like atom. So let us now one by one discuss the expression for radius, etc. Let us talk about radius first. Let us talk about the radius of nth orbit. In case of hydrogen or hydrogen-like atom, you have to derive the expression for the radius of nth orbit. Now you consider the situation in which you have the nucleus here. The charge here is Z times electronic charge, and the electron is revolving around it. Let us suppose the radius is R. This is the radius R you are saying, and this electron has certain mass and it will be having certain velocity. Now going by the Bohr's postulate, the first postulate said that Z is square by 4 pi epsilon naught R square. This is equal to mv square by R, isn't it? This was the mathematical expression of the first postulate you had. And the second postulate said that electrons are permissible only in those orbits in which the angular momentum is integral multiple of h by 2 pi. These are the first two postulates you have. Now in case you cancel this R and this R square, and you take out the value of V from second equation and substitute into the first one. You understand? अगर आप यहाँ से 1R use करके एक R square की R को cancel करें, and after that if you substitute the expression of V from this place into this place, तो आपको radius का expression इस तरह से obtain होगा, epsilon naught h square n square by pi me square z. This is the kind of expression you will be getting. Now you see, in this expression, accepting this n square and z, you have all other expression to be a constant. अगर आप यहाँ से यहाँ तक ये सारी values देखें, तो this is a kind of constant. If you substitute the values of these constants, remember that epsilon naught is permittivity of vacuum, h is Planck's constant, m is mass of electron, E is electronic charge, and n is nth orbit, maybe second orbit, third orbit, then value of n will be 2 and 3, and Z is true for different atoms. अगर ये हाइड्रोजन का केस होगा तो Z की वैल्यू 1 लेंगे, अगर हीलियम प्लस का केस होगा तो Z की वैल्यू 2 लेंगे, and so on. So in case you substitute all these values, then you will find that radius of nth orbit in terms of some constant can be written as 0.529 n square by Z angstrom. If you remember this expression in this particular format, then you will be in a position to solve questions very easily. क्योंकि हो सकता है हम आपसे बोलें कि हीलियम की फोर्थ ऑर्बिट का रेडियस आप निकालें, देन दैट मीन्स हीलियम के लिए Z की वैल्यू 2 आप सब्स्टिट्यूट करेंगे, एंड अगर उसकी फोर्थ ऑर्बिट की वैल्यू निकालनी है तो n की जगह 4 हम सब्स्टिट्यूट करेंगे, एंड देन यू कैन कैलकुलेट द वैल्यू ऑफ रेडियस ऑफ एनी ऑर्बिट फॉर एनी हाइड्रोजन लाइक एटम. Now here a very important concept you have to remember, that radius was proportional to n square. This is a kind of expression you should always remember कि radius n square के proportional होती है. Now once you have discussed the expression for radius, let us now talk about speed in nth orbit. Let us talk about speed of electron in the nth orbit. Speed of electron in the nth orbit. For that, again, try to remember the second postulate. You have mvr is equal to nh by 2 pi. So from here, if you set up the equation for the speed in nth orbit, then it will be v proportional to, rather you can write it for equality, this v is equal to nh by 2 pi mr. I am writing down this proportionality because I am not interested about h, 2 pi m and so on. If you write down the first orbit expression, in case you substitute all these values, you will find that the velocity of electron in the first orbit of hydrogen atom, that comes out to be c upon 137. Here c is the speed of light. So this is a kind of data you should always remember. For ready reference, this will be very much handy and useful. So आप ये याद रखेंगे कि this is for hydrogen atom. हाइड्रोजन एटम के फर्स्ट ऑर्बिट में इलेक्ट्रॉन की जो रोटेटिंग स्पीड है वो c अपॉन 137 के इक्वल होती है. एंड फॉर अदर ऑर्बिट्स you can see that once you have written here v proportional to n by r, rest of thing is equality. यहाँ पे आप इक्वालिटी का साइन लगा सकते हैं, बट प्रोपोर्शनलिटी में h and 2 pi m all of them are constants. It is only n and r, so v is proportional to n by r here, and since r is proportional to n square, so you can also say this is n upon n square, and for that matter v becomes proportional to 1 by n. That means what? That means अगर आप सेकेंड ऑर्बिट में इलेक्ट्रॉन की स्पीड देखेंगे तो वो फर्स्ट ऑर्बिट की हाफ होगी, अगर थर्ड ऑर्बिट में देखेंगे तो फर्स्ट की 1/3 होगी, बिकॉज जैसे जैसे एन की वैल्यू इंक्रीज करती जाएगी वेलोसिटी की वैल्यू लेस होती जाती है. एंड वट एवर डिस्कशन यू आर मेकिंग हियर रिलेटेड टू इलेक्ट्रॉन्स, सिमिलर काइंड ऑफ डिस्क्रिप्शन वी हैव ऑलरेडी गिवन व्हेन वी टॉक्ड अबाउट सैटेलाइट मोशन. देयर द न्यूक्लियस रोल वाज बीइंग प्लेड बाय द अर्थ and the electron was analogous to the satellites. So there also you have seen that once the orbit of the satellite is getting far off, or you can say the radius of orbit is increasing, then the speed of revolving satellite that also decreases, and that is well depicted here by the increase in value of n. अगर small n की value धीरे धीरे आप increase करेंगे तो velocity of revolving electron that will also decrease. Now you see in this particular context we can also talk about the frequency of rotation. Let us suppose I talk about frequency. Then you could have also said that V is equal to omega r, and this is proportional to n by r. Now if I talk about the dependence of frequency on n, so I can say frequency is n upon r square, and once radius is proportional to n square, so this is again proportional to n upon n raised to the power 4. Therefore frequency, this becomes proportional to 1 by n raised to power 3. अंडरस्टैंड, अगर फ्रीक्वेंसी की एन पे डिपेंडेंस हम डिमांड करेंगे तो वो 1 बाय एन क्यू के प्रोपोर्शनल होगी. एंड इन केस वी डिमांड द डिपेंडेंस ऑफ टाइम पीरियड, देन यू सी टाइम पीरियड विच इज जस्ट द रिवर्स ऑफ फ्रीक्वेंसी, दिस विल बिकम प्रोपोर्शनल टू द क्यूब ऑफ एन. टाइम पीरियड nth ऑर्बिट के क्यूब के डिपेंडेंट होगा. दिस इज द काइंड ऑफ थिंग यू कैन हैव. नाउ based on this, let us suppose I ask you a question that once the electron is rotating, it is definitely like a current carrying loop and it must have been creating magnetic field at the center. So let us ask you that how is magnetic field dependent on n? Let us talk about that. Now let us suppose I ask you a question. How is the magnetic field? How is the magnetic field created by the rotating electron? Here it is understood that the magnetic field we are talking about, that is created at the center. जो इलेक्ट्रॉन रोटेट कर रहा है, how is the magnetic field created by the rotating electron dependent on n? n is the principal quantum number or orbit number you can say. उस पर कैसे डिपेंडेंट है? जैसे अभी आपने यहां पे देखा था, फ्रीक्वेंसी वाज प्रोपोर्शनल टू 1 बाय एन क्यू, टाइम पीरियड वाज प्रोपोर्शनल टू एन क्यू, रेडियस वाज प्रोपोर्शनल टू एन स्क्वायर एंड सो ऑन. तो यहां पे हम मैग्नेटिक फील्ड के लिए यही क्वेश्चन आपसे हम पूछ रहे हैं. नाउ सी, फर्स्ट ऑफ ऑल ट्राई टू अंडरस्टैंड दैट द एक्सप्रेशन ऑफ मैग्नेटिक फील्ड विल बी रिटन एज म्यू नॉट आई अपॉन 2 पाई आर. Expression for magnetic field will be written as mu naught I upon 2r this way, and I की वैल्यू जो है वो आप चार्ज इंटू फ्रीक्वेंसी भी लिख सकते हैं. इफ यू रिमेंबर द करंट वॉज रिटन एज चार्ज इंटू फ्रीक्वेंसी, एंड बाकी सारी क्वांटिटीज एज इट इज हमने लिख दी हैं. जो जो क्वांटिटीज इसमें कांस्टेंट है हमने उसको छोड़ दिया. और मैग्नेटिक फील्ड की अगर हम डिपेंडेंस देखें ऑन प्रोपोर्शनैलिटी, वी कैन से इट इज प्रोपोर्शनल टू फ्रीक्वेंसी अपॉन रेडियस, इजंट इट? नाउ यू सी, फ्रीक्वेंसी यू हैड सेड इट वाज प्रोपोर्शनल टू 1 बाय n क्यूब. जस्ट नाउ you have derived that frequency is proportional to 1 by n cube and r is proportional to n square. So if n square is also multiplied here, then ultimately we get that magnetic field is proportional to n raised to the power minus 5. Understand? Magnetic field is proportional to n raised to the power minus 5. This is the kind of dependence you will be having so long as the dependence of magnetic field on the principal quantum number is concerned. Now continuing with this, in case I also demand that how is the magnetic moment, how is the magnetic moment of electron dependent on if you remember magnetic moment, we had said that it is current into area. This is the kind of expression we had in the discussion of magnetic field. But in the context of describing the gyromagnetic ratio, we had also said that dipole moment, magnetic dipole moment or magnetic moment which you say, that is related to the angular momentum like this. अगर आप मैग्नेटिक डाइपोल मोमेंट और एंगुलर मोमेंटम की रेशियो देखते हैं तो दैट वाज चार्ज अपॉन ट्वाइस ऑफ मास, एंड हियर रेस्ट ऑफ थिंग्स आर कांस्टेंट, सो यू कैन से दैट magnetic dipole moment is proportional to the angular momentum, and angular momentum is a fixed quantity so long as Bohr's postulate is concerned, and that is equal to nh by 2 pi. For that matter, you can say the magnetic dipole moment that is dependent on n like this, simply directly proportional to n. If you feel like you can derive it in other fashion as well, if you want, you can write magnetic moment as current into area. Now current will be again charge into frequency dependence, you already know this is 1 by q, and r square, that will be n raised power 4. So n raised power 4 upon nq, again you will be getting the same kind of answer. So you have two choices, either you can represent the magnetic dipole moment in terms of angular momentum, or you can use the independent basic formula that this is equal to current into area. So these are some of the questions dependent on n you should always keep in mind so long as the Bohr's model is concerned. Now the third derivation we should be concentrating on, that is the energy of the nth orbit. Let us talk about that.